My name is Rebecca Edmonds, and this is my science fair project for MASC 320, and my project is based on different kinds of filtered water. So the research question is, will filtration differences in water affect the evaporation duration or the residue left behind? Will College Station water, Sugarland water, distilled water, and bottled water evaporate differently or leave behind different residues? My hypothesis in general is that the least filtered water will leave behind the most residue, while the most filtered water will leave behind the least residue. My prediction is that College Station water is the least filtered water, and so it will leave behind the most residue, then Sugarland water, and then bottled water, and finally distilled water. I do not believe the filtration differences will affect the evaporation rate or duration. This is my list of materials. Everything that you see here, the Sugarland water, which has a filter worked into the plumbing, so it is slightly filtered. And then the College Station water, which is not filtered whatsoever. And then the bottled water, and the brand is Ozarka spring water. And then the distilled water, and the brand is Hill Country Fair. And finally, HEB to-go cups. And then I have some pictures so that you can see where the water comes from. My dependent variables are the evaporation duration and the water residue. My independent variables are the 4 water types: the Sugarland water, College Station water, bottled water, and distilled water. My controlled variables are all the water types are stored in a room with the same temperature and humidity. So the temperature and humidity are controlled. And then all the water types are stored in the same sized container and the same type of container, so the container is also controlled. And then each has 2 tablespoons of water regardless of the type. So the amount of water is controlled. The controlled variable, which I compared the other 3 water types to, was the distilled water. My procedure and methods were as follows. First, each of the HEB to-go cups were marked or labeled. That way I knew which one was which, and then they were filled with the corresponding water type. So I filled the College Station water with 2 tablespoons of College Station water, and then the Sugarland water with 2 tablespoons of Sugarland water, and so on. The cups were set aside in a heat and humidity regulated location, and they were checked regularly to monitor their size. I checked them every second day or every other day. Finally, the data was collected and analyzed. And then these are pictures of the 4 results. So the bottled water, as you can see, had a few residue spots left, and then the distilled water had barely imperceptible residues that you had to hold up to the light to see. And then the Sugarland water had a very thick, almost crusty-like residue coating the outer part of the container. The College Station water had the same type of residue as the Sugarland water, but it was less consistent. There were just a couple of drops here and there. This is the data that I collected. So the first day, the 17th, all 4 containers of various water types were measured at 4/16 of an inch tall, and the water's height was measured directly after measuring out the 2 tablespoons of water. Then on the 3rd day, the 19th, the College Station water and bottled water both measured to be 2/16 of an inch tall, and the distilled water measured to be 2.5/16 of an inch tall, while the Sugarland water was 3/16 of an inch tall. The 5th day, the 21st, the College Station water was already down to little drop clusters, measuring to be 1/16 of an inch tall. So I just measured each drop and they were all 1/16 of an inch. And then the distilled water and bottled water still fully encompassed the bottom of the container, but they were also at 1/16 of an inch tall. And the Sugarland water measured to be 2/16 of an inch tall, covering the bottom of the container. On day 7, the 23rd, the College Station water had evaporated completely, leaving a white, almost crusty or flaky looking residue. One of those was almost an inch and another was 10/16 of an inch, and the last was 6/16 of an inch. The Sugarland water had a couple more drops than the other two. However, the drops from the bottled water, Sugarland water, and distilled water were each 1/16 of an inch tall. And the 9th day, the 25th, the Sugarland water had a thick white residue covering the bottom outer circle of the cup. And again, this was rather crusty or flaky looking. The distilled water had only one almost clear, tiny residue that was 4/16 of an inch, and the bottled water had one large residue mark that was 11/16 of an inch, a few that were 2/16 of an inch, and this was slightly more visible than the distilled water. However, both of them were fairly hard to see. And then this chart just shows everything that I just said. The analysis and findings were as followed. I made a graph and then I showed the corresponding colors. The water type which possessed the most rapid rate of evaporation was the College Station water. Then the bottled water and distilled water were equal, and the Sugarland water was the slowest. The water which left the most residue was the Sugarland water, then the College Station water and bottled water. My hypothesis for the order of the amount of residue was almost accurate. The Sugarland water left more residue than the College Station water, although the Sugarland water was more filtered. My hypothesis for the water evaporation was incorrect, since I thought that the water type would not affect the duration of evaporation, since the College Station water evaporated the most quickly while the Sugarland water was evaporating very slowly, and then the distilled and bottled water evaporated at almost the same rate. When a person cleans their dishes and lets them dry, the person can use this experiment to know which water type will evaporate most quickly and which will leave the least residue. And then they can use this knowledge to their advantage as they let their dishes air dry. And their dishes can look cleaner and more pretty and less water stained. Another application is for a person who enjoys hot beverages. If they wish to scrub their tea kettle, or the distilled water left the least amount of residue, instant kettle less often, then they can use this information to find the best water type, such as distilled water, to leave the least amount of residue so that they can scrub their tea kettle less often. If I were to redo this investigation, I might use more water or perhaps repeat the experiment twice to gather more accurate and more detailed information. And I might also include different water types. In this experiment, a teacher could touch on the forms that water goes through and what causes the changes in the forms, or mixtures, and how they can be separated. And then you'll see the two following techniques that the teacher could use. Thank you so much for your time, and I hope you enjoyed my science fair project. Have a wonderful day.